Hello, everybody, and welcome to another SIG Windows meeting. It's the 8th of October, and as always, please adhere to the CNCF Code of Conduct. This is a recorded meeting. All right, well, let's dive in first into the document that Patrick created. Thank you, Patrick, for basically doing all the work on basically capturing the different problems around multi-architecture, multi-platform, container images, and how we can make them run better in Kubernetes. Patrick, you want to take it?
Yeah, I've actually got two items on there. The one sort of tees up the discussion for the other. Okay, so the first one is in Kubernetes 1.16, they added a new feature called runtime class scheduling. And what that lets you do is basically, your runtime class is another object that's part of the Kubernetes API that was promoted to beta, but it gives you the ability to put node selectors and tolerations on based on the runtime class that was requested. And so that means that you can simplify a deployment such that instead of needing to put all the node selectors and tolerations in it, you can just put the runtime class name within the container spec itself. And so that way the cluster admin can basically say, here's a list of runtime classes that we have on the cluster, pick what's appropriate for your needs. It could be as simple as just specifying Windows or Linux, or it could have some more features unlocked behind it, because there's also this runtime class handler that is passed down to the CRI layer. And that's interpreted by, cryo, containerd, whatever's running underneath there, and it can, tweak different parameters that are outside of the Kubernetes API. And so like one of the examples that people use today is if they want to do things, with a sandbox like Kata, Firecracker, or gvisor, they would define a runtime class for it, set the handler to be, one of those, and then that's how those configurations get applied. But all the specific things like the memory size and number of CPU cores used by the sandbox are not stored part of the runtime class. That's actually configured on the node itself. And so the first step I did was I've got a PR to the docs that we had that were already there on the Windows scheduling guidelines that basically say, if you want an easier way to deal with node selectors and tolerations, you can go ahead and create a runtime class and use that instead. And so that's kind of the first PR that I've got there. And this doesn't actually require any code changes. It works in 16. So moving forward, one of the key questions that I'm kind of working around is when we want to start enabling isolation like Hyper-V and use that to solve some of the difficulties that we have with dealing with multiple versions on Windows, using runtime class with that handler is a way that we could address that solution without API changes to the pod object itself. And the reason that works is because we could basically specify a runtime handler that says enable Hyper-V and then create a sandbox using a particular Windows version. The problem that we have today is that the CRI still doesn't know to use a runtime handler when we do an image pull. And so that's something that we would have to change, but it's a smaller scope to change than changing the pod itself. And so what I aimed to do in this document was sort of outline some of the user problems that we have today with dealing with multi-arc and multi-OS images. And, in a way that, the whole kind of workflow makes sense and we can have a discussion across multiple SIGs with it. And so the the three different options that I had sort of outlined for fixing this problem at a high level are, one of them is doing some work in the scheduler such that it would be aware of multi-arc images and then be able to make some decisions around that. And that's something that people have voiced concern against in the past. And, Derek and Ravi here are continuing to voice concerns against it. The second approach is, rather than changing the core scheduler itself, we could defer some of that work off into a mutating admission controller. This would mean that the concerns they raised are still valid, but it's something that a cluster admin would opt into by deploying that admission controller. So they could say, if I want to, have some magic to basically make it easier for customers to, or for the, the developers and the users that are deploying applications to, get the best fit on a node, we could have some magic in an admission controller, but it's going to mean that every deployment on my cluster is going to take longer to make those decisions. The one kind of mitigation to that is that the cluster admin could still say, here's a list of best practices, and if you follow all these node selectors and stuff appropriately, your workload schedules faster. Otherwise, it might get slowed down. And so it's kind of at least it takes a trade-off out of the Kubernetes code and into another project, but creates some extra day 1 and 2 headaches for the cluster admin to deal with. The third option is basically continuing to take advantage of the node selectors that we have there today, and then basically taking some extra things that are needed for isolation and basically doing that in an opaque manner using the handler field. And so what this would mean is an admin would go create a plethora of runtime classes. You might call it something like, it might be done on a per Windows version, and then they might multiply that based on some other hypervisor parameters, like the number of cores they want to allocate to that VM. And so you could quickly get a very big matrix that's difficult to maintain and not portable. However,
so Patrick, on that, I do agree that, in a nightmare scenario, they might have multiple Windows versions with Hyper-V or without Hyper-V, and it could get complicated. But in a realistic production scenario, they're very, very likely going to have a little bit of homogeneous environment, right? So they're not going to have 3 Windows OS versions of production. They might have, for a single cluster, 1 or 2 maximum OS versions, and very likely just 1. So that's why also the runtime class is my preference for this option as well.
So the problem comes when you go to deploy a new Windows version. You basically have to update these runtime classes, and it's going to change the behavior of where things run. And so if you're not adding new runtime classes as you do that, then you're basically in a situation where you're going to change the behavior of how things are getting deployed and then hope nothing breaks.
No, I agree that you should create new runtime classes when new OSs are introduced, right? So I do agree with that. I'm just saying that in a production environment, it's unlikely to have multiple Windows OS versions as their nodes.
Okay. I'll add some updates reflecting that here. Okay. So the other problem we need to solve is that based on the Windows versions there, we still don't have any sort of standard way to tag those on Windows nodes. You know, we've proposed using something that's not under Kubernetes.io as a label that an admin could go, you know, just choose to apply on their own. And so one of the things that I'd like to consider doing is actually having the kubelet report the kernel version in a new standard field. And so that way we'd be able to not have to do that extra step for the admin whenever those are added into the cluster. And so that's something that I'm going to discuss with SIG because that would make dealing with the multiple Windows versions easier for sure. The other related thing is that once we get into working with Hyper-V isolation, the way that the node selectors work, I believe you can only match on a specific version. And so that means that we would need to basically, like if you wanted to move from running a particular version container like 17 or like 1809 onto using Hyper-V isolation on a new version of Windows, you'd have to go change on your runtime class, which means nothing would be scheduled to your old nodes anymore. Every new deployment would go on from there because these labels would, or sorry, these node selectors would need to be applied at scheduling time. And so if you ran into problems with Hyper-V isolation and you wanted to roll back, you can't do it on a per app basis. It's an all or nothing thing. And so to avoid that problem, we'd basically have to go back into the runtime class expansion and then use some other field that's there to sort of be able to steer workloads around on a per app basis. And so it's not like, you know, we could work around it, but it's something that, you know, continues to explode the number of runtime classes that are needed, you know, if we're going to only use node selectors that are there. And so the third option, which is, I would argue is architecturally the cleanest, is to actually move forward with, hold on, let me find what I was looking for here. Yeah, so the other option that we were looking at here is that we could potentially update the CRI to actually go ahead and support specifying, you know, the OS version and the the OS version and the architecture all as part of the pod spec itself. And let me find that section here. I may have only put that in the other doc now that I think about it. Yeah, I'm confusing the two docs because I was working on both of them yesterday. But that's going to be the broadest impact change because it would actually change the Kubernetes pod spec itself. And yeah, so the fields that would need to be added would be OS architecture and version, and then that would need to be part of the pod spec itself in order to basically undo these workarounds and do things completely deterministically from the scheduler all the way down to the nodes. So, kind of the summary that I'm proposing for 17 is that I think that we should go with a solution that gives us that has kind of like a narrow scope of impact, but still allows us to do the experimentation we want with Hyper-V. And so I think what that would be is that if we can add the runtime handler field to pull in the CRI layer, then that would mean that we could basically pull mismatched OS versions and then also use that same runtime handler to specify the OS version and architecture that's used by containerd when actually creating the sandbox and then launching the container. So it gives us something that's deterministic all the way through, but lets us figure out what the right set of things are that we want to control at the containerd layer without having to go and break Kubernetes APIs while we're doing that. And if we do want to do some experiments around a mutating admission controller, then that gives us the ability to do that as well. And then, so if we're happy with the way that works and we've got a reasonable set of runtime classes that are going to work for most scenarios, then we could just go ahead and say, when we graduate to stable, here's the runtime classes that are recommended as defaults, and then work to make sure that those are kind of used uniformly across multiple distributions and or cloud providers. And so, I mean, I think that's probably the easiest thing in 1.17. If we realize that the runtime class expansion is not a clean, is too difficult and not clean enough, then we could still go back with SIG node and look at the alternate approaches of actually moving the OS version and architecture into the pod spec itself. So this doesn't preclude that, but I think it at least gives us a path forward that we can make progress on 1.17 without getting blocked.
And the reason we are holding back on the pod API changes is because they're API changes and will take a while.
Well, I don't have any support from SIG node on that yet. So if in 10 minutes they have full support for it, then I think we should go ahead and do it. But when we've talked about this before, there was resistance to it. The other thing is that I don't have the people to do it. And so we'd have to, so in addition to getting the specs done to do that, between SIG Windows and SIG node, we'd have to find a few more volunteers to step up and make those changes, because we would need to update, like when we update the API, that means we need to update API server, we would need to update the scheduler, and the scope of those changes is a lot wider than just updating the kubelet, which is what would be needed for what we have here today, because the since all the fields to the CRI, we wouldn't need to change the other layers. And so that would basically mean it's an alpha feature that could be, maintained by within the auspices of SIG node.
Makes sense.
Okay, so I guess the next step is for everybody from SIG Windows to, if they haven't reviewed the spec, this document, to go ahead and do that. And then depending on how the conversation goes with SIG node after that, you'll add some more comments and edits to the doc, and we'll fix. If SIG node is not sitting behind this in terms of amending the pod spec with the new fields for OS architecture, then you'll move forward with the runtime class option. Just for 1.17, and then we can reevaluate this moving forward if we need to.
Well, so I mean, we can move forward. We're going to move forward with the runtime class either way, but if we don't get the update to the CRI pull action, that means that Hyper-V is out. I mean, we wouldn't be able to get the benefit of running multiple versions on the same cluster. And the only other workaround we had before was using an annotation, but that was done as a hack in Docker shim, because at that point it still had a copy of the deployment spec that had the annotations. Like, there's no pod level or container level annotations that I'm aware of that we could use to enable this feature.
Got it. So yeah, I won't be able to attend the SIG node after this, but let us know how it goes. If there's anything I'm assuming they also have issues with resources, but let's see what they say, and if it's something small that we can make an investment in, and it's just a matter of convincing them that it's the right approach, I can help on that.
Okay. Did anybody else have feedback on that? Okay. I guess we can go on to the next thing on the list. Okay,
right.
So GMSA?
Yeah, it's GMSA and PROW, so both of them are Deep and Jeremy. Go ahead, guys.
So I just looked at the two GMSA PRs. Looks like for the testing one, Adelina provided some feedback and it's been LGTM. So I think we're good there, right?
Yeah.
Okay, excellent. So it'll be a matter of just enabling the E2E test, doing some more Sandkey runs and enabling it. For the other docs PR, that's been languishing for a while. I just saw some updates just before this meeting though from one of the reviewers, so I'll address that and get it moving. The other thing I had after that was, we were working on the CSI proxy stuff, and we were wondering, like, so basically the context here is all the CSI projects are driven through PROW as part of their release and testing. And I know we have discussed this a little bit before, but was there any guidance around like how to enable Windows nodes for PROW?
I haven't had any time to look at that yet.
What's the current state of things? Like, do we have Windows tests running on PROW today or not?
Well, so today PROW with the Azure provider is basically spinning up Azure VMs, and that works for test passes that are orchestrated through test grid, but we don't have anything that during the time of doing a Kubernetes build that a Windows node is provisioned for either building containers or doing unit tests.
So there's no support for any tests on Windows right now other than just nightly tests?
Other than which tests?
The test grid nightly, yeah.
Yeah, test grid.
Yeah, that's the state today.
Okay. Would it be really frowned upon to use something like AdBayer or Circle CI in the meantime?
I mean, we could definitely do that, but the thing here is that we were trying to get something that was all triggered and orchestrated through PROW, so that way things like pushing the test images and promoting them into the GCR repositories and stuff like that all just worked. And so if we have a separate, desynchronized process that doesn't get rid of the manual steps.
Yeah, but it's better than nothing for now. It would be nice to have a way to run automated tests on CSI proxy right now without having to rely on people actually manually running tests.
Yeah, I mean, since it's a separate repo, I would say we could just do it.
Okay, cool. We'll do that.
I don't see any reason not to. We just don't. I just don't know if we can get a webhook set up on the main repo that would trigger that.
Would you want the main repo in KubeCube?
Yeah.
Yeah, I mean, CSI proxy is not vendored in KubeCube, so
yeah,
no problem. Cool. Thank you.
Yeah, and so I think that makes sense, because that way we could have something that would run on every check-in there.
For now, yeah.
Okay. And crap, unfortunately, I got to run over to the SIG node meeting now. So I'm sorry,
Yeah.
Jeremy.
Hey, Jeremy, I'll push it to the agenda for next week if that's okay with you.
Yeah, I just wanted everyone to take a quick look at it and if they had any suggestions before I make a PR.
So that's the troubleshooting doc for networking.
Yes.
Okay. We do have a troubleshooting section in our notes in the contributor guide. Would this not fit better there?
I didn't realize that was in there. I can change that.
Can you look at the contributor guide and create a PR of that? I'll send you a link on Slack.
Okay. Thank you.
Thank you all. Appreciate it. Have a good day, guys.
Alrighty. Have a good one. Bye.
See you. Bye.